The living planet. Life on Earth could never exist were it not for a series of very fortunate coincidences, some of which were unknown or poorly understood until the 20th century. Those coincidences include the following: Earth's location in the Milky Way galaxy and the solar system, as well as the planet's orbit, tilt, rotational speed, and unusual moon. A magnetic field and an atmosphere that serve as a dual shield. Natural cycles that replenish and cleanse the planet's air and water supply. As you consider each of these topics, ask yourself, are Earth's features a product of blind chance or of purposeful design? Earth's perfect address. When you write down your address, what do you include? You might put in your country, city, and street. By way of comparison, let's call the Milky Way galaxy Earth's country, the solar system, that is the Sun and its planets, Earth's city, and Earth's orbit within the solar system, Earth's street. Thanks to advances in astronomy and physics, scientists have gained deep insights into the merits of our special spot in the universe. To begin with, our city, or solar system, is located in the ideal region of the Milky Way galaxy, not too close to the centre and not too far from it. This habitable zone, as scientists call it, contains just the right concentrations of the chemical elements needed to support life. Farther out, those elements are too scarce. Farther in, the neighbourhood is too dangerous because of the greater abundance of potentially lethal radiation and other factors. We live in prime real estate, says Scientific American magazine. The ideal street. No less prime is Earth's street, or orbit within our solar system city. About 93 million miles, or 150 million kilometres from the Sun, this orbit lies within a limited zone that is habitable because life neither freezes nor fries. Moreover, Earth's path is almost circular, keeping us roughly the same distance from the Sun year-round. The Sun, meanwhile, is the perfect powerhouse. It is stable, it is the ideal size, and it emits just the right amount of energy. For good reason, it has been called a very special star. The perfect neighbour. If you had to choose a next-door neighbour for the Earth, you could not improve on the Moon. Its diameter measures just over a quarter of that of the Earth. Thus, when compared with other moons in our solar system, our Moon is unusually large in relation to its host planet. Mere coincidence? It seems unlikely. For one thing, the Moon is the principal cause of ocean tides, which play a vital role in Earth's ecology. The Moon also contributes to the planet's stable spin axis. Without its tailor-made Moon, our planet would wobble like a spinning top, perhaps even tipping right over and turning on its side, as it were. The resulting climatic, tidal, and other changes would be catastrophic. Earth's perfect tilt and spin. Earth's tilt of about 23.4 degrees causes the annual cycle of seasons, moderates temperatures, and allows for a wide range of climate zones. Our planet's tilt axis seems to be just right, says the book Rare Earth: Why Complex Life is Uncommon in the Universe. Also just right is the length of day and night, a result of Earth's spin. If the speed of rotation were substantially slower, the days would be longer, and the side of the Earth facing the Sun would bake, while the other side would freeze. Conversely, if the Earth were to spin much faster, the days would be shorter, perhaps just a few hours long, and Earth's rapid spin would cause relentless gale-force winds and other harmful effects. Earth's protective shields. Space is a dangerous place where lethal radiation is common and meteoroids are an ever-present danger. Yet, our blue planet seems to fly through this galactic shooting gallery with relative impunity. Why? Because Earth is protected by amazing armor, a powerful magnetic field, and a custom-made atmosphere. Earth's magnetic field. The center of the Earth is a spinning ball of molten iron, which causes our planet to have a huge and powerful magnetic field that stretches far into space. This shield protects us from the full intensity of cosmic radiation and from potentially deadly forces emanating from the Sun. The latter include the solar wind, which is a steady stream of energetic particles, solar flares, which in minutes release as much energy as billions of hydrogen bombs, and explosions in the outer region or corona of the Sun, which blast billions of tons of matter into space. You can see visible reminders of the protection you receive from the Earth's magnetic field. Solar flares and explosions in the Sun's corona trigger intense auroras, colourful displays of light visible in the upper atmosphere near Earth's magnetic poles. Earth's atmosphere. This blanket of gases not only keeps us breathing, but also provides additional protection. An outer layer of the atmosphere, the stratosphere, contains a form of oxygen called ozone, which absorbs up to 99% of incoming ultraviolet or UV radiation. Thus, the ozone layer helps to protect many forms of life, including humans and the plankton we depend on to produce much of our oxygen, from dangerous radiation. The amount of stratospheric ozone is not fixed. Rather, it changes, growing as the intensity of UV radiation rises. So, the ozone layer is a dynamic, efficient shield. The atmosphere also protects us from a daily barrage of debris from space. Millions of objects ranging in size from tiny particles to boulders. By far the majority of these burn up in the atmosphere, becoming bright flashes of light called meteors. However, Earth's shields do not block radiation that is essential to life, such as heat and visible light. The atmosphere even helps to distribute the heat around the globe, and at night the atmosphere acts as a blanket, slowing the escape of heat. Earth's atmosphere and magnetic field truly are marvels of design that are still not fully understood. The same could be said of the cycles that sustain life on this planet. Natural cycles for life. If a city's supply of fresh air and water were cut, and its sewers blocked, disease and death would soon follow. But consider, our planet is not like a restaurant, where new food and supplies are shipped in from outside and garbage is carted away. The clean air and water we depend on are not shipped in from outer space, nor is waste matter rocketed out. So how does the Earth remain healthy and habitable? The answer? The natural cycles, such as water, carbon, oxygen and nitrogen cycles, explained here and shown simplified. The water cycle. Water is essential to life. None of us can live without it for more than a few days. The water cycle distributes fresh, clean water around the planet. It involves 3 stages. 1. Solar power lifts water into the atmosphere by evaporation. 2. Condensation of this purified water produces clouds. 3. Clouds in turn form rain, hail, sleet or snow, which falls to the ground ready to evaporate again, thus completing the cycle. How much water is recycled annually? According to estimates, enough to cover the Earth's surface uniformly to a depth of more than 2.5 feet, or 80 centimeters. The carbon and oxygen cycles. As you know, in order to live, you need to breathe. To take in oxygen, and give out carbon dioxide. But with countless billions of humans and animals doing the same thing, why does our atmosphere never run out of oxygen and become overloaded with carbon dioxide? The answer lies in the oxygen cycle. 1. In an amazing process called photosynthesis, plants take in the carbon dioxide that we exhale, using it and the energy from sunlight to produce carbohydrates and oxygen. 2. When we take in oxygen, we complete that cycle. All this production of vegetation and breathable air happens cleanly, efficiently, and quietly. The nitrogen cycle. Life on Earth also depends on the production of such organic molecules as proteins. A. To produce those molecules, nitrogen is needed. Happily, that gas makes up about 78% of our atmosphere. Lightning converts nitrogen into compounds that plants can absorb. B. Then plants incorporate those compounds into organic molecules. Animals that eat those plants thus also acquire nitrogen. C. Finally, when plants and animals die, the nitrogen compounds in them are broken down by bacteria. That process of decay releases nitrogen back into the soil and atmosphere, completing the cycle. Perfect recycling. Humans, with all their advanced technology, create countless tons of unrecyclable toxic waste annually. Yet the Earth recycles all its waste perfectly, using ingenious chemical engineering. How do you think the Earth's recycling systems arose? If the Earth's ecosystem had truly evolved by chance alone, it wouldn't possibly have been able to reach such a perfect level of environmental harmony, says religion and science writer M.A. Corey. Do you agree with his conclusion?
How would you reply? Do you feel that the Earth's features are the product of purposeful design? If so, which of the above facts do you find most convincing? How would you respond to the claim that the Earth is nothing special, just another setting where evolution could occur, teeming with life? No one knows how many species there are on Earth. Estimates vary from 2 million to 100 million. How pervasive is life on our planet? Earth. Just 100 grams or 3.5 ounces of soil has been found to host 10,000 species of bacteria, not to mention the total number of microbes. Some species have been found almost 2 miles or 3 kilometers underground. Air. In addition to the birds, bats, and insects that fly through the air, the atmosphere is filled with pollen and other spores, as well as seeds and, in certain areas, thousands of different kinds of microbes. The diversity of microbial life in the air is on par with the diversity of microbes in the soil, says Scientific American magazine. Water. The oceans remain largely a mystery because in order to study the watery deep, scientists often have to use costly technology. Even coral reefs, which are relatively accessible and are well surveyed, may host millions of yet unknown species. Did this impressive variety of life arise by chance? Many would agree with the poet who wrote, "How many your works are, O Jehovah! All of them in wisdom you have made. The earth is full of your productions." Psalm 104:24.